I think I am live now. Can anyone confirm if audio, video, etc. looks great? Then we will start solving problem. People in the chat, like, do let me know how many problems were you guys able to solve today? I was able to solve all of them, but so I would definitely discuss all the problems. This problem was definitely much harder for a Dude 3 contest. I would most likely rate it more than 2000. So that's where we are. Uh, so, like, also let me know if audio, video, etc. everything looks fine, and then we will get started. So, yeah, like, looks like a large majority is up to three problems, and then we have four problems. Yeah. Let's wait for a couple of more minutes, and then we will get started if more folks want to join in. And yeah. Mhm. So this is where we are. Mhm. Thanks, man. Like, bro, cooked. I could solve only A, B, C, D, F1. Like, okay, interesting. What was E? Let me quickly check. Yeah, like, problem was definitely on a bit harder side, and that's where we are. Yeah, like, the first three problems were relatively easy, but then we have like F1. Solved two, but they were F1 and F2. Nice. So yeah, like, let's get started now. First problem says Debir, Ego, and Arseny just got on a train and decided to play a game. Debir has a backpack with an infinite number of cubes. He built n towers from them. The height tower has hi cubes. Igor and Arseny must choose an integer xi for each tower and increase its height by xi exactly once. For example, if initially heights are 1, 3, 2, 2 and x equal to 3, 2, 2, 8, then after increasing h, it will become 4, 5, 4, 10. Like, what you add 1 to this 3, and then we had like this 3 to this 2, this 2 to this 2, and this 2 to this 2. Their goal is to make height of all of the towers equal. To make game more interesting, Debir wants to choose an integer k and add a restriction that each xi must be between 1 and k value. Help him find the smallest k for which it is possible to finish the game. And by the way, like, there are just five numbers and all the numbers are 1 to 6, but we don't really need it. So, like, overall, like, the problem statement is like this. Overall, like, the problem statement is like this. Mhm. Like, we have an array of numbers. One second, let me check why my pen is not working. Yeah. So we have an array of some elements. Let's say these are the heights. We can add some value to each of the elements. So if we, let's say, the new element we want to add is 2, 4, 5, 6, and so on. So our new element becomes like some of these two values. Here it would be 3, 6, 6, and 16. What problem statement asks us to do is, like, we have to make all of these elements equal. And since all the elements are at least one, if we have to make all the elements equal, then let's first look at what is the maximum in the array. Let that so like because we have to do plus one even for the maximum, the largest element after doing this plus would be at least max plus one. And what we can do is like we can try to make all the elements equal to max. Array all elements equal to max. With this, we can figure out how much we want to add to each of the elements. And maximum addition would be required on the minimum of the array. Will be in why it would be like this would be the final array of each of the element and minus whatever the minimum in the array is. So we need to ensure that all the we are allowed to have one height which is equal to this value. So like k must be at least equal to this value, and that's where we are. And overall, like the idea was like we want to make like the problem statement looks like this, like we have a given array, we want to make all the elements of the array equal, and we have to add some positive element to each of the array. And let's try to do in such a way that the maximum element in the new array is in minimized. So this was problem A. Let's say what is the minimum possible value of new element. Because we are going to do plus one in all of the elements, like this is the like we are like all the elements, if we want to make them equal, then they should be at least equal to this. Max that's required. Then in that case, like whatever new element we want, we have to make it at least all the elements at least equal to this element. And now we can simply print this as the value of k. And this was problem A actually. Any questions, anyone on problem A before we jump on to problem B? So this is where we are. So let me know if there are some background noise or something, and that's where we are. This was problem A, friends. Let me know if you have any questions on it, else we will jump on to problem B. So as like let me know, you can probably react or something, but let's move on to problem B then. Tatar TV Show. During the holidays, Igor came to visit his friend Dabir in the city of Karjan. Out of boredom, Dabir and Igor came up with a new business idea to make their own TV show. The format of the show is simple. In each episode, they invite a guest and play a game with them on a binary string. In today's episode, Igor and Dabir invited Arsni. the main celebrity of Omsk OMSQ. For the game, they choose a binary string as of length n and an integer k. Arsni can make an unlimited number of moves. In one move, he can choose an integer I and invert the characters at position I and I plus k. That is, change 0 to 1 and 1 to 0. For example, if s equal to 110, 110 and k equal to 2, if we choose I equal to 2, then the fourth and the second and the fourth element would change. Arsni inverts the character at position 2 and 4. So 110, 110 becomes 11100. Arsni wants to get the maximum price of 10,000 targets. To do this, he needs to make the entire string equal to 0. Help Arsni determine whether he can get his price or if he will have to return Omsek with nothing. So the problem statement says we are allowed to do an operation of form, like we can choose two integer indexes which are k elements apart, and now we can invert both of them. We are initially given a some string s, and can we make all of the elements equal to 0? So for example, let's say we have k equal to 3 and our initial string is this 110, 111, 0, 110, something like that. Then if we choose this as the index, then we can change these elements to we can flip these elements. So this 0 will be 1 will become 0, this 1 will become 0. Or for example, if we choose these two elements, if we choose this index, then these two elements will be chosen. And now if we are doing a flip operation here, then this will become 1, this will become 1. So we are allowed to do as many operations like this, and the problem statement asks us to figure out if we can make all the elements equal to 0. Any questions, anyone, on the problem statement before we jump on to the solution? So like the overall idea would be like this. Let's first look at the very first element. Like this is our string, let's say 110, 110, 10. If this first element is 1, then we will have to do one operation where this element and this element is chosen. Otherwise, there is no other way to make the first element equal to 0. So like the idea would be like we have to change this element to 0 and we have to flip this element. Now once the first element is 0, then we can look at the next element over here. Now this element is also 1. Like the new string becomes like this 0, 1, 0, 1, 0, 1, 0, 1, 0. Now we have to look at the second element. This is also 1. So we have no choice but to do operation with this and with these elements. So now we can choose these elements and make these to 0. And like so on. Like that would be the overall idea. Like once the first element is 0, we can remove it from the array and forget that it exists. This would be the overall idea. You go from first to next element. If any of the element is 0, you do an operation then and there and also change the corresponding element next to it. Once you are done with all the operations like this, you have to check the remaining string. Like you cannot make an operation over here because there is no I plus 3 over there. So you try to do fix all the elements which you can, and at last check are all the elements equal to 0 or not. If the all the elements automatically become 0, then you print yes, otherwise you print no. Like that, this would be the overall idea for this problem. Like there would be more ideas that people would have tried for it. For example, they would have taken the count of ones for each index modulo k or something like this, and they would have checked all the elements are even or not. And like that would be where we are. And like that would be a few more other ideas over here, but since it's problem B and order and solution is allowed, that's where we are. So we start from all the elements. We go from I up to the index we can make an operation with. In this case, we can make operation up to n minus k only. If the current element is 1, we change that to 0, and then we look at, like, let's just write a function. Change si to 1, else change si to 0, like, because the element would be 1. Now we do a flip at index I and flip at index I plus k. So this is where we are. At last, we have to check if any of the element is 1, then all elements are not 0. And at last, if all the elements are 0, we print yes, otherwise we print no. And this would be the solution for problem B. Any questions, anyone? E, please. Okay, I will move on to one after the other. I am starting from the easiest problems first and try to wrap them first. Any questions, anyone? Like, let me know if you have any questions on problem B. Otherwise, we will move on to problem C. So this is where we are. Yeah, like, it's easier to overcomplicate this problem. Like, you would have tried taking indexes modulo k or something, then counting all of them are even or not, but you don't need it in this case. So, okay, sort matched up the poll. I did not solve 7, I solved 6. I think that's fine. So this is where we are. So let me know if you guys have any questions on problem B, otherwise we will move on to problem C. Let's move on to problem C then. Omsk Programmers. An annual programmers fair is taking place on the main square of Omsk. You, as the main programmer of Omsk, decided to take part in this wonderful event and went there. At the entrance, a guard decided to check your skill and gave you a problem. You are given three integers a, b, and x. You want to make a and b equal. In order to do so, you can apply the following operation. Choose one of the integers a and b and add 1 to it. Choose one of the integers a or b and divide it by x by rounding down. You need to find minimum number of operations after which a becomes equal to b. Can you prove your skills, or you will have to go back down? So, like, the overall problem statement says you are given two integers. We can either add 1 to any of the integers, or we can divide one of the integers by k, and we have to round down if it's not fully divisible by k. And it asks us to find minimum number of operations we need to do to make both of the elements equal. So, like, actually there is no concept of n square over here. Like, it's a, b, and x only, not really n square. So what are the strategies to solve after problem B? Like, you can probably join my Discord server and check roadmap to red, or you can probably wait until the end of the video and ask what are questions. Yeah, like, greedy will definitely not work over here. Any questions, anyone, on the problem statement first? Yeah, like, I will discuss all the problems. So this is where we are. Is this recursion? Like, you can technically call it a recursion, or you can don't you can skip calling it a recursion. Like, that doesn't really match. And that's where we are. Like there are many crazy ideas you can do over here, and they most of them will work. So, like, any questions anyone on the problem statement before we jump on to the solution? So yeah, like actually the most crucial observation here was first you have to do all the divide operations, and then you have to do some addition operations. Like let's look at it this way. Like let's say we have k equal to 3, and let's say we have some element a. Let's say we have a equal to 16. Now let's say we want to do two operations on it, divide by k and do a plus 1. If we do 16 plus 1 first, which becomes 17, and then we divide by 3, the new element becomes 5. But let's say if we don't even do any operations on it, then our element is 16 divided by 3, that also gives us 5 here. So if you see in a case like this, we have actually ended up wasting one of the plus 1 operation. Okay, if our goal is to make a equal to 5, then it's better if we simply divide it rather than doing an addition operation and then dividing it. Going via this route requires us to take two operations, but going via this route requires us to take only one operation. And this is actually minimizing it. And at the let's say, on the other hand, let's say if we want to do it this way, 16 plus 1, which becomes 18, and then divided by 6, it gives us 6. On the other hand, if we go via this route, 16 divided by 3, which becomes 5 plus 1, it gives us 6. This route required us 3 operations, 2 plus 1 and 1 division, 3 operation here. And this route required us to take 2 operations here. And like for example, like the question is right, if the number is let's say 17, then if you do 17 plus 1, which is 18, divided by 3, which becomes 6, or 17 divided by 3, which becomes 5 plus 1, it becomes 6. Both of them required the same number of operations. Like that's where we are. Overall, like you can prove it. Like first dividing it and then doing addition would be the most optimal way to get the required number. It can actually be the same number of operation, or the number of operation would actually be quite less. But you will never really need more operations over here. Like the way I would put at it is like this. If I have AI, I will have to do some plus operations, and then when I divide, this each of the plus one's contribution is effectively 1 by k. Like this is where I would look at it. Okay, if I do a plus 1 divided by k, or a divided by k plus 1, then whatever number I want to form here, this plus 1's contribution is effectively 1 divided by k. Then isn't it better ki we first divide and we do plus 1 over here, so like all the plus operations contribute more to it. You can probably take a step further as well. Let's say you want to do a plus 1 and then divide by k and then divide by k, or you do a divide by k plus 1. Here this plus 1 is effectively contributing 1 divided by k square on each plus 1. That's why like it's always optimal to first divide and then do plus. Divide and then do plus operations. Any questions, anyone? Yeah, like first dividing and doing plus 1 is effectively like you are doing plus k initially, something like that. Yeah. Yeah, like I think it's fine to assume ki it would divide. That's better. Like, but this is actually the proof here. Any questions, anyone on this observation first? Once we have this idea sorted, then we will jump on to like how to solve this problem. So like rather than proving optimal now, like this fails. Can you probably say why this fails? Like now the next idea is like if you don't want to make any more observations, like what you can do notice over here is like the numbers are up to 10 to the power 19 and the value of x is up to 2. So what is the maximum? No, this doesn't fail for a equal to 2 as well. Let's say I just want to divide zero number of times. Like I am saying, first you divide how many times you want to do, and then you do the operation. In this case, you don't need any division operation. So it's not doing division operation any number of times is same as saying you divide zero times and then make the elements. Like what is the maximum number of times we can divide a by x? What is the maximum number of times? Like you will notice that since we have numbers up to all the numbers are up to less than 10 to the power 9, if we divide it 30 times, the new number would be 2 10 to the 10 by 9 divided by 30, and this value is actually 0. You can mathematically take it like this, log 2 of 10 to the power 9, something like that. But now this is the main observation we have. Like the maximum number of divisions you need on each of the numbers is 30. Like because when you divide a number by 31 time, after 30 divisions, the number becomes 0. Then dividing it more does not gives us any better solution here. And the moment you realize this, like any questions over here, like it's not better to divide more than 30 times in any of the numbers. Because we know that for each number we would be first dividing it and then doing some operation. Then like number of divisions you need is at max 30. Now at a minimum what you can do is you can brute force number of divisions for a between 0 to 30, brute force number of divisions for b, which would be again 0 to 30. And once you have both of these, whatever numbers you are remaining, now you know that all you have to do is plus 1 for this. So like once you are done with these divisions, all you can check is what is the difference of the remaining numbers after this division, and that would be the number of addition operations you need for whatever element the smaller is. Plus 1 on smaller element. So like this is the idea you can always do. Like now there are all more gritty ideas over here. I will jump onto them, but let's just code it over here. Like these are the bare minimum observations you need for this problem. So let's say we have v. This gives what is the value we would get after we divide b by 1. If we don't have to divide anymore, the value remains same. Otherwise, we can say we can divide v by once, and then we can say we need I minus time more as well. Or let me just put it this way. Like this gives us like how many times we have to divide over here. Now maximum number of divisions we need is 30. We can run a for loop to figure out how many divisions we do for A. After division, like the new operation A will become this. And like, for example, if new A is less than equal to new B, then you can do plus operations here. Else we need to increase B over here. And we can take minimum of answer, comma the number of operations we needed over here. And this would be the number of operations you need over here. Any questions, anyone on problem C? And let me know if you did something else. Wait 1 second. This gives me a TLE. Okay, we have test cases up to 10 to the power 14. So like we can try to optimize it further, but this is where we are. Sir, I did like A divided by K greater than or equal to B. I divided what's the flaw in it? Like it's at times it would be optimal to both divide A and B by some things. So like this idea is actually giving us a TLE. One more thing we can do is we can probably try to pre-compute the divisions operations. You can keep it pre-computed. That will decrease some time complexity for you. And this actually will solve this problem. And this is one way to solve this problem. One more thing that we can do over here is like we can look at it like this. Like let's say we have numbers A and B, and A is less than equal to B. That's fine. Either we don't do any operations, don't do any division operation. Then we know how many operations we need to do, which would be B minus A Like that would be the difference. Or let's say if we do some division operations, then if we do A divided by K, then this increases the gap between A and B. This increases gap between A by K and B, like this would be the new number. So if we are doing dividing A by K, then it is also optimal to divide B by K. Gap. We should also divide do B by K. Like, does this sound fair? Like, let's say one option is we don't do any division operation. That's fine. You can directly look at the gap and do. Otherwise, if you are dividing A by K, then the two numbers, I am assuming A is less than or equal to B. Then if you divide the smaller number, then the gap between that smaller number and maximum is also increasing. So for the larger number to chase smaller number, it's better to divide larger number by K. Or even if we don't divide by A divided by K, and even if we don't divide by, then also it's optim. Then also, like, we can try doing division by K as well. Like, because if we are going to do any division operation and we are not doing division operation on A, then it's better to do division operation on B as well. Because if we have to do some division operation, either we will do it on A or we will do it on B. Like, there is no number C over here. If we are doing division operation on B, then that's fine. But if we are doing division operation on A, then also we have proved that it's better to do division operation on B. So in any case, we definitely know that if we are doing a division operation, then we will do one division operation on B only. Yes, if we do a division operation, then we will definitely do B divided by K. So this solves the problem. Either we take an answer by not doing anything, or we divide by B by K and then try to solve the same problem again. So this is where a recursive solution will come in. Where you have A, B, and X, you need to find the minimum operation. No, it doesn't give any TLE. If A is greater than B, then we can swap A and B. Either we don't do any division operation. If A is equal to B, then we don't need to do anything. Or we do a division operation by dividing B by X. And this will also give us the required answer value. And this is where we are. So any questions, anyone? Like, this would be a recursive way to solve this problem. Like, people in the chat, do let me know if you have any questions from A to C. If there are no questions, then I will move on to the next set of problems, which would be from D problem. Do react something so I do know that you have understood all the problems so far. So this is where we are. Like, I did while A greater than equal to B, like just doing operations on A is not enough. You will have to also do operations on B as well. And like for each after each division, you have to take look at what's the minimum. Like if you have your solutions handy, you can actually look at the actual test cases as well. Like you can find test cases here to find where your problem is failing. So this is where you are. Like the recursion idea is like this. Okay, I have two options. One, yeah, you can also use a for loop to do it. Like that's how I did it in the contest. Like the idea is either we don't do any division operations, then we are assuming A is less than equal to B. If we don't do any division operation, then the number of operations we need is B minus A. That is one option for us. Or if we are doing division operation, then I am saying like we have to definitely divide B by K. So we take one operation and then divide B by X. Now our new numbers are A, B divided by X. And now we have to solve the same problem again. Now we have to find minimum operations. Using this as the starting pair. And this is where we are. So like this is where the recursion comes in. We have this function solve that gives minimum operations when you have A, B, and X. If both the elements are equal, then we don't have to really do anything. Otherwise, if A is greater than B, or another way to put it is like I am saying, either we don't have to do anything, or we have to at least divide the larger element. And this is where we are. Any questions, anyone on problem C? Else we will move on to problem D. Like I will move to problem D if I don't see any questions from anyone, and do react something so I know that we can move on to the next problem. So let's move on to the next problem. So like the problem D is as follows. Dabir and Igor were not satisfied with the fame from the previous episode, so they decided to make TV shows. The guy plays their favorite game on an array A with their favorite number K. Dabir moves first. On the first move, any element from the array can be chosen and removed. Let the previous chosen element be equal to X. Then on the next move, except the very first one, a player must choose an element Y from the array such that 0 is greater than equal to Y minus X is less than equal to K. Like this equality is a bit important condition, and remove it from the array. So like whatever element someone has chosen right now, You have to either choose current number or you have to choose plus k up to plus k of this and remove that element from the array. The problem is like the player who cannot make a move loses the game. But since this was not just a game but a real show match, Artsni, the main celebrity of OMSK, was invited again. As a guest celebrity, Artsni was given the opportunity to make the first move in the match, that is to make the very first move in the game instead of Dabil. However, it turns out Artsni is a fan of Ego, so he wants his first move to guarantee Igor a winning strategy against any response from Dabil. Determine whether Artsni can make the first move for Dabil so that no matter how Dabil plays, Igor wins. So this is a game theory problem. I had my own ideas, but I will just check if an editorial is out or not. Like if there are some simpler solutions, then I will slightly prefer discussing them. Or like if you have some simpler ideas, do let me know. Otherwise, I can always definitely I will definitely discuss whatever I have solved so far. Mhm. This due 3G is definitely not hardest due 3G I have seen, but it was definitely not for due 3. It would have been the due to E or F, something like that. So I don't see multiple different ideas for this problem. So let's try to solve a game theory problem. By the way, if you guys are interested, you can actually check my video on how to solve game theory problems, where I have tried to solve the Grundy number problem, not the best one, but like this video, I believe would definitely be useful. So you should definitely solve this, watch this video, like where I have explained how to solve game theory problem using one more Codeforces problem. This problem is actually harder than the current problem we are discussing, but I am discussing the general ideas on how to solve this problem. So this is where we are. I believe it's possible to do some casework over here, but I tried prefer to going the vanilla way. So like the overall idea is as follows. Let's just sort all the elements. Like my primary idea is as follows. Let's just sort all the elements. Now the only reason I am doing is I have now this array. Rather than removing some element, I would say like my active segment for game is some suffix of it. By active segment, I would mean like let's take one of the sample example. Let's say our element is 3, 2, 5, 6, 1, something like that. Then if we sort the element 1, 2, 3, 5, 6, I am saying like if I have removed 2 from the array, then the next person will only choose elements from this. Then let's say if I have removed 5, next person has removed 5, then the remaining element for the next person is only 6. So like if the array is sorted, then game is always played on some suffix of this array. So once we are done with this, one more operation is like it's not optimal to have elements with frequency less than k 3. I don't think we really need it, but if we want frequency of any element is greater than equal to 3, we can remove two elements from it. Two occurrences. Essentially, we can do a minus equal to 2. Although it's not required, but that's where we are. So my next idea was, let's say if the last element someone has removed is 10 and k is equal to 3. And let's say the array looks like this: 10, 10, 10, 12, 12, 13, 15, 19, so on. Now, if someone removes 10, then I would say like this first 10 is removed and the remaining element is on this part. Or if someone removes 12, then the remaining game is on these elements. Or if someone removes 13, the remaining game is on these elements. Like, I'm not sure what do you mean by trading or something. Like, at least the frequency greater than 3 was one observation that I have ended putting up here, although you don't need it for the solution. The idea for frequency, let's say if an element appears 5 times, is in an optimal move, if anyone, people, like you can probably mirror the other opponent's move to decrease two elements by one if it's not favorable for you. Like that observation is actually not required, but I just gave it for you. You can try to prove it. So, I'm saying it this way: if AI is the last element removed, who will win? Who will win? Like I am trying to solve for this problem. I have already made all the elements sorted. So what I'm saying is someone has to remove 10, then they have to find the first index of 10 and remove it. So your remaining game becomes the on the remaining part. Or if someone is removing 12, then they will not remove this 12, but they will remove the element which is the smallest index for 12, and so on. This way you still have suffix with all the still remaining elements of this. Now I am saying if AI is the last element removed, who will win? Like that's the problem statement for us. So this is where we are. Like I believe few people tried some segmentary with. Okay, all the elements were between 1 to n. I did not realize this observation. So what you can try to do is one segmentary solution idea can be like this. Let's say I start from decreasing element, try to figure out who will win over this. I saying if the current person is removing here, is removing here, then next person will remove anything between. An element from AI up to AI plus case, something between. Like this would be the move for the next person, right? So the question is there any winning position? Next person has any winning has any winning number? AI up to AI plus one. If the answer is yes, if the answer is yes, then if you take AI, then the next person will just choose the winning number and the game will be over. Next person will pick this winning number. If the answer is no, then we have lost. Then we have won actually. Because whatever the all the choices the next person has, they cannot choose anything between them. So this way we can figure out for each index, if we start on that index, who will win. And like you can probably use segment tree to query on a range to figure out if there is a winning position on that or not. And we also know that the first person who is playing wants like the other person's ego to win, right? Because the first person is Arseny, he wants ego to win. So first Arseny will play, then Igor will play, and then Dabir or Dabir Igor would be the way. So like the winning sequence is like this: Arseny, Igor, Dabir, Igor, Dabir, and we want Dabir to win, right? Igor to win. So Arseny can try to choose numbers in such a way that it has at least one winning position for Igor. It has winning move for Igor. And again, like we have to honor the constraint that whenever we are removing element x, we have to choose the smallest index where x exists and we have to remove it. So this is where we are. So you can do segment tree over here. Then coordinate compression, etc. Two pointers are the ideas. That I will not go into the details, but you can look at my submission to read them. For segment tree, I would actually use Adcoder library. First, I take all the numbers and I just sort in. First, I have to find the starting position for all the elements. Well, let's the first index. Or I can rather keep it -1. Or the smallest index after sorting, that also works. and this is area. Now we can choose segment tree. Segment tree just says for a given range, do we have a winning position or not? If any of the elements have a winning position, then overall the range will have a winning position. And the default is false, that the range does not have a winning position. All the numbers are up to 1 to n, so we need to have segment tree up to n plus 1 of length n. Or we can x is up to 1 to n as well, right? Or x is very large. And like it doesn't really matter, we can take now we start from the larger index. The number of elements we need is from x plus k. We cannot have elements more than that. The current position is losing if there is a winning position from L up to R. Like this is an open interval. If this is a losing position, then if first index of x starting index is this. First starting position is this. Like starting position is the small first place where each of the element exists. And we also maintain an boolean. If Igor one we would print true, otherwise we would print false. If the current position is losing, and if current index in that position, then Igor has won. Nevertheless, if current position is losing, that's fine. We don't have to do anything. Otherwise, we have to set current index to be true. Because now we know that the X index is definitely winning. Any questions, anyone? First index. Wait 1 second. Looks like something is wrong here. Mhm. POSI. Uh-huh. Otherwise, we need to send X to false. Like so, this was overall idea for problem D. Now we can submit it for problem D. Like I know, like the idea may not be simple. Like, can you please let me know whatever questions you have on this problem? I will try to resolve them before we move on to the next problem. Like the overall idea is like what I am saying is like we are working on some suffix of the sorted array. Now, whenever we are at some index, we can try to note like what all elements we can choose from here. And we are maintaining like if we choose X, then does starting from X leads us to a winning move or not? Here I am setting that if we start from X and now whatever suffix we have right now, that would be a losing position or that would be a winning position. Could you dry run through an example? Definitely. Like give me some number. And let's say our k is 4. Then if I choose 10 in the very first move, there are no numbers remaining. So David will win over here. So if in the first move, if someone has 10 as the only remaining move, then David would be winning over here. Now let's say if the okay, let me put it this way. If the last number removed is 10, then the next person cannot win. So whoever has picked this number will win, right? Whoever is picking 10, they will definitely win. Because if once you choose 10, there is no remaining number over there. Now, if we have 7, if someone picks up 7 in the current move, then the next player can choose between 7 and 11, somewhere between them. And they know that if starting player picks 10, then he will win. So that is the reason why if anyone removes 7, then they cannot win. Because the idea is if someone removes 7 from the array, then the next player can remove any number from 7 to 11. And we know that whoever is going to remove 10, they will definitely win the game. So removing 7 cannot be a winning move. Now let's go to 5. If I am removing 5 right now, the next person can remove numbers only between 5 to 9, right? Because our k is 4. And if I check all the elements from 5 to 9, if I remove this number, then there is no winning number over here. Like overall idea is like I choose some number and I see what my next up player can choose. If they have a winning move, then I lose. If all of their moves are losing, then I win. So is it safe to say in this case, if anyone who is removing 5, they will definitely win the game? Because the idea is if I remove 5 from the array, the other person will remove something between 5 and 9. And we have checked all the numbers which are between 5 to 9. Removing them will definitely make them lose the game. Now I go to this 3. I will remove this 3 when I have only one 3 remaining in the array. If anyone removes this 3, like let's first forget these elements don't exist. Then if anyone removes this 3 from the array, then the next player can choose anything between 3 to 7. And we know that because removing 5 is a winning move, removing this 3 is definitely not a winning move. Because if I remove this 3, next player will remove this 5 and game will continue. if I have two threes in the array, and let's say I remove one of the threes from here, the next player will again choose something between 3 and 7, and they can again choose this 5. So this 3 is also a losing move. So, like if you have two threes in the array, then also you cannot win by removing one of the three. Because the moment you remove one of the three, next player will remove 5 and we lost. Now let's say if we have three threes in the array, and if I remove this three, then also next player can choose anywhere between either one of these two threes or 5 or 7. They will definitely choose 5 and I will lose the game. So even removing this tree is not winning for me. Now, if I have two, if I remove two right now, next player can choose anything between 2 and 6. They will choose this 5 because this 5 is winning. So even removing this 2 is not, I cannot win. Let's say I also had 0 here. Now, what happens if I remove 0 from the array? Then next player will choose something between 0 and 4, right? Because my case is 4. And you can choose, see that all the elements between 0 and 4 are actually losing. So if I am removing 0, then I can definitely win because whatever move the next player will play, that's losing for them. So now this 0 is a winning move for me. This way, I am trying to figure out which indexes are winning moves, which indexes are losing moves. And now, because the first person Asni wants David to win, he will choose one of the elements that's losing for him. In this case, if Artsni picks removes this, then Igor cannot win. David will win because like that's a winning move. So Artsni will not pick these elements. Artsni will definitely can pick this element because after this Igor can choose 5 and he can win. Or Artsni can remove this 3 so that only two threes remain in the array so that the game is played on this suffix. And then also Igor can choose 5 and he can win. Or Artsy cannot remove this 5 because the moment Artsy removes this 5, Igor does not have any winning move. So Artsy will skip this element. But Artsy can definitely remove this 7 because the moment he removes this 7, this is losing for David. Igor can pick 10 and they are done. Artsy can, if Artsy chooses 10, then there is no move for Igor because this 10 is a winning move and that's where we are. So Arsenal will definitely not choose 10. So Arsenal can choose 2, 3, and 7 to get Igor winning, and that would be the overall solution for this. Okay, like some folks in the chat have an idea. Like, let's first look at the largest element. So, any questions on the previous idea we have? I am pretty sure some greedy based on the larger, smaller elements like this exists, but this is how you will have to usually solve the game theory problem. Like overall idea is, let's say if I play this move, what are the other moves for the next player? And I will try to make the game into a position such that all the positions are losing for the next player. Like I can definitely look at. Let's look at Igor's solution, whether he is winning or not. So find all the index, find frequency of this. This is an interesting one. Mhm. So, like, this code is actually neat. What it's trying to do is it's making a claim. Okay, like if we have two elements with difference less than k, let's say k is 4 for r, and if we have 3 and 5 in the array, then if 5 is winning, then if someone removes this 3, then let's say if 5 is winning, then if the first person removes 3, then the next person will have moves from 3 to 7, and they can choose 5 and they will win. Or if this 5 is losing, then Arseny can just remove this 5 from the array to get David losing. Like, do you see what David is doing? It's first the claim is like either the game will end with Igor not doing anything at all, or Arseny will play in such a way that Igor has a move where he can win. So like it's saying like if there are any two elements with difference less than equal to k, then one of the starting position is definitely losing. The crux of the idea is like let's say if we are 3 and 5, if 5 is the if someone picks 5 and they win going over the our previous idea, then what Arseny can do is he can remove 3 so that Igor can remove 5 in the next game and he can win the game. Or if 5 is losing, then David can what he can do is he can simply remove Arseny can simply remove this 5 and David started with the losing position and he is done. So if there is any possible move in the more than one move in the game, then Igor can definitely win. That's actually the first condition. Otherwise, what you have is like your array would look like this: 3, 3, 3, 3, 5. The difference of all the elements is more than 10. So whenever you start, only those moves can be played. So you will like let's say in this case, if you have k equal to 4, all you can do is you can keep repeatedly remove 3 from the array. You because you don't have numbers between 4 to 7 here. So we just count the frequency of threes. If it's even, then the game can be like I remove first, next player removes one, I remove one, next player removes other, I remove one, next player removes one, and so on. After even number of moves, we are done. So if any number appears even number of times, then David can remove that so that after even number of turns, all the elements would be higher. Or if all the elements are odd, then David will win. So this is what neat idea this person does. If frequency of any elements is even, then we can start by this element and we will definitely win. Otherwise, we cannot win whatever how much rigged the game is. And this would be the problem D. Actually, this is the neat idea, but I did this did not struck me, so I ended up doing some 2 pointers or something. Instead of segmentary, you can even use 2 pointers there. If you want, you can look at my in contest submission later of the at the end of the video. So instead of segmentary, you can also try to use 2 pointers here. That I will just put the submission access for the curious folks. And I plan to move to problem E. Let me know if there are any questions remaining on D. If yes, I will try to answer them or just do a react thumbs up or something so that I can move on to the next problem. Okay, let's move on to E then. Arjun decided to make his friends Dabir and Igor happy. For this, he decided to give each of them an array of numbers of same length. An array B is called good if its elements can be rearranged so that for all I, the condition bi minus bi equal to 1 whole true. So essentially, it says an array is good if all the elements are consecutive elements. Archni wants Dabir and Igor to be able to play with this array. For this, the following condition must be satisfied. Like basically, we have to first find two elements, two arrays, sub arrays from this part, which are taken from two different places. Both the arrays individually should be good. So both the arrays individually should have equal number of elements. And if we combine both the arrays, then also the new array should also be good. Arsni has an array of length. He plans to cut both the arrays from the array. That is to choose two non-overlapping segments of the same length. Help Arsni determine maximum possible length of the resulting subarrays. Is my voice echoing? Or like you can probably check if the Codeforces contest tab is running somewhere or that's the case. So like this is where we are. Overall idea would be as follows. So overall what we have to do over here is I think that's fine. Overall what we have to do is we have this original array with us. We have to choose two subarrays such that each of these have all the consecutive elements. This also has all consecutive elements. And we combine these two. Then also we again get a consecutive elements. How do we find if an array has a consecutive elements? Like first condition is all the elements should be distinct. Second condition is maximum element should be equal to minimum plus length minus 1. Like, are these two conditions look sufficient to everyone? Or do you have any questions like why this condition is sufficient to figure out all the elements are consecutive and distinct? Because the idea is if no element is remaining, if the smallest element is 2, if you have 4 and 5, if anything is missing between them, then the largest element will definitely be more than the differences over here. So now the crux of the problem is like the numbers are up to 6,000 only. So we can technically do an order n square solution here. And you can notice that all the elements are between a to n as well. So what we can do is we can do it as follows. We have this array A, right? What we can do is like, let's say the second array is like this. We would have some index I. That would be the division point. Let's say we have found, 1 second. Let's say this is the division point for us. We have found an array of consecutive elements of length 5 here. And the elements are between 3 to 7. Or let's say the elements are between 8 to 12. Then what we have to check is, do we have any array of consecutive elements between 3 to 7 in this side, or 13 to 17? If we can somehow figure this out, then we can solve the overall problem. Right now we have found an array of length 5. And then we move a bit further. Like the idea is, I am dividing the array into two halves. I am picking some elements from the right side and some elements from the left side. Now what I can do is, I can move this boundary a bit further and try to look at what more segments I can find over here. Let's say this would be one element of consecutive segment. This would be one element of consecutive segment, and so on. For each segment, I will try to check if this segment has the required parts or not. And what do I really need to do over here? Like whatever segments that were already existed, that was fine. Only new good segments that can come up over here would be the ones that involve these elements. And that's where we are. So I'm maintaining two things. I have some starting index I, that I would first say, like overall, I am saying like this. I have an index I that I am keep incrementing. Every time I would first check how many good segments can exist that start from I. For each of the segment, I would see if left side has the corresponding half or not. Then I will merge this I with the left side and I will move my segment to the next position. And I would keep doing it. At last, I would be able to figure out if I have all the required elements or not. So like this would be more on the coding side, but overall this was the idea for this problem, and like we have already discussed the relevant observations we need. Any questions, anyone on the observation so far? Like this is a 2D array. L comma R is true if there exists and segment which contains all the consecutive elements from L to R. Now I am starting out all the elements. So I'm first trying to iterate on all the segments that start from IDFs. If I have already seen V, then I will break here. Now the elements are no longer distinct. Otherwise, I keep a track of minimum and maximum. If minimum is equal to, if maximum is equal to minimum plus length minus 1, then this is the good element we have found. Now we have to check if we have any segment with minimum to minimum on the left side. If yes, then our answer is maximum common length. Or we have any element with max. Then also we have found the other good half and we are done. Hello, hello. Like out of range, we don't find any element. Otherwise, good left, left, right, we have already pre-computed it. Hello, hello. The next we would do is, then I will try to move this current element to the left side. Hello. Hello, hello. Okay, voice is okay. Thank you. Then I will try to do is, I will assume current index to be the right element and I will iterate on the left element over here. If I have already found it, otherwise I break, the same condition remains again. If this is good, then I will just mark all the elements are good and overall, I think that's fine. So overall, this would be the idea. The segment is, you have some elements for the left segment and then you have the right segment as well. You first look at the all the good segments that start from the current index and see how many good. Whenever you find a good, you check if you can find corresponding pair for the good segments on the left half. Based on that, you take the maximum length and then you move the current index to the left segment and you keep repeating it. And like this would be problem E actually. Mhm. Wait 1 second, we have to also mark visited VS. Mhm. Not sure which part is giving me a WA. Okay, this should be next first line. Hmm. Any questions, anyone on problem E? Else we will move on to problem F. So, like the idea is like this. Like before the start of this loop, let's assume I have found all good segments. Like I am just checking has two boundary conditions only. If I have all the good segments from array A0, A1 up to AIDX minus 1, and I am putting it based on the left side in this array. This is a 2D array. Here, if 2 comma 5 is good, that means there is a segment that contains all the elements between 2 to 5 as a consecutive elements. Now I am looking at good segments that start at AIDX and check if pair exists in left side or not. I am maintaining the same set of conditions. I am keeping this variable seen before. Iterating from the current element, try to add more elements to it. If I have seen current value before, then I stop it. Otherwise, this ensures that all of my elements are before. See, I update this scene before. I update my minimum, I update my maximum, and I also see like what is the length that has been covered so far. This variable ensures that all the elements are distinct. This variable checks all the elements are consecutive. If this is true, then we know that AIDX up to AR is distinct elements from minimum to maximum. Now, what are the choices of the other half? minimum minus length and up to minimum minus 1. That's one choice for the left half. Like if I find some element, some segment that is consecutive element for these elements, then my problem is solved. This would be the length number of elements that exist on the left half. AIDX to AR is the another good segment. Or maximum up to length would be the other element that I would check in the left half. If I don't want to use that array, that also fine. In this case, I update my answer like this length is one possible value to figure it out. Once I am done inspecting on all of this side, move IDX to left side. We already know all the good segments. For the array A0, A1 up to AIDX minus 1. Now, new set of good segments will be some element AL and so on and up to AIDX. Like this would be the new set of good segment that can come up. So I run the same loop again. Same two set of conditions. Now I'm moving on the left endpoint, assuming the right endpoint is my current element. If I have seen current element before, break it, otherwise take min maximum. I know the length. If this is a good segment, then I mark that on left hand side I have found one good segment which is between minimum and maximum. And doing this would overall be order n square, and that solves the overall problem. So like the has left was only checking some variable, but you don't strictly need it. So this is where we have. Any questions, anyone on problem? If not, just give me a hands up, then we will move on to F1. Okay, it's not DP. Is it good left? So like that's the only approach I would say. Like we have order n square allowed, so you can do it this way. You can possibly check in comment section if there are any more approaches, but I believe that's all. If this work gives me a thumbs up or something so that we can move on to the next problem. Any questions, anyone on the first five problems? Because I believe based on my poll, like most of the people were able to solve 1 to 3 problems. Some people were able to solve 4, and then few people were able to solve 5 and 6. So I believe like these are the problems where the most of the people would be stuck at. So if you have any questions or anything, let me know. Else we will move on to the next problem. If not, then let's move on to problem F. Problem F is a special case where x is equal to 1. On the way home after buying his favorite soda, Zero Cola, Cola Zero, okay, it becomes Zola Hero. Let's just say Diet Coke. On the way home after buying his favorite soda, Diet Coke, Igor saw the election for the position of best number are taking place in his city. There are n people at the polling station. Each person bought a number AI. When the ith person enters the room, they choose candidate that is a divisor of AI. Let the chooser number be PI. After everyone has voted, we get an array of votes, which is PI up to PN. Ego really likes the number X and considers the voting ideal if X into LCM of all the numbers is equal to the product of all the numbers. Help him find the number of different arrays modular 10 to the power 9 plus 7 that are ideal. So in this case, we are being given that X is equal to 1. Any questions, anyone, on the problem statement before you jump on to the solution? So overall, what we have to do is as follows. We are being given an array. We have to find an array P such that each PI is divisor of AI and LCM of P is equal to product of P. First question, like when can this equality hold true? Like let's say, what is the formula of LCM of A multiplied by B divided by the GCD of A comma B. So LCM for two numbers is same equal to product only when GCD is 1. If we have three elements, LCM of A, B, and C, we can make LCM of A comma B, and then we take LCM with C. In our case, what we first need is GCD of A comma B becomes 1. If that's the case, then this would be equal to A into B, and LCM of A B would again be GCD of A into B comma C is also 1. Then only this LCM would be equal to ABC. Using these two facts, you can also derive that GCD of A comma C should be 1 and GCD of B comma C should be 1. So overall the TLDR is all the elements, all pair of elements should have GCD equal to 1. They have GCD equal to 1. Like GCD of PI comma PJ is 1. Any questions, anyone, on this observation? Like you can try to figure it out based on the previous conditions. First, we got GCD of two elements, first two elements, like because when you figure, like you can keep making it a bit further. When we have to take LCM of two elements, we need GCD 1, then only its product. Now, when we have to make GCD of three elements, you first take LCM of two elements, because you know that this GCD of these two elements is 1. So you replace it by A into B. Now, when you take LCM, this should be equal to the product. That can happen only if GCD of first element and second element is 1. If you have two elements with GCD 1, then if you take any divisor of the first element and any divisor of the second element, then also GCD is 1. Or another way to put at it is like this: no prime number should divide both elements. Because if there is a prime number that divides both of the element, then that prime number would be a factor of GCD. Or like if we don't have to do it this way, then let's look at it in a more different way. Let's say we have P1 is equal to Q1 to the power R1, Q to the power R2, Q3 to the power R3, and so on, where Q is prime number and R is the power of that prime number. Similarly, we have P2 equal to Q1 to the power some separate R, or I will probably let's keep it as. So on. If we have these two numbers, then what is the LCM for these two numbers? Q1 to the power maximum of R1 comma S1, Q to the power maximum of R2 comma S2, Q3 to the power maximum of R3 S3. Can I say it this way? If I have to put in the other alternative definition of the numbers, like the way I am putting it like this: if 2 to the power 3 divides one of the numbers and 2 to the power 7 divides another number, then LCM should be divisible by 2 to the power 7 into some value, and B is 2 to the power 7 into some value. Then LCM would be A comma B would be 2 to the power 7 into some value. Because the idea is like LCM divides both A and B. So LCM also divides all the factors of A and B. And if I have 2 to the power 7 as one of the factors, then LCM must divide 2 to the power 7. Does this sound more intuitive? And in this case, you can notice that LCM would be 2, 3, and 6. LCM is 6, and product is 2 into 3 into 6. What we need is LCM equal to product. And this does not hold true because product here is 12, LCM is 6. This is because there is at least one prime factor that's dividing both of the numbers. So what I am saying is, let's find how many times 2 divides each numbers. Let's say for the first number it's 2 to the power 3, second number it's 2 to the power 0, third number it's 2 to the power 7, fourth number is 2 to the power 4, fifth number it's 2 to the power 1, and into some number. LCM will contain the maximum of all of this, which would be 2 to the power 7 into some number, and product will actually contain 2 to the power 3 plus 7 plus 4 plus 15 into some numbers. And in this case, these cannot be equal. So the only way these numbers can be equal is only one number is more, everything else is 2 to the power 0. Then only, like, on one side we have 2 to the power maximum power, on another side we have 2 to the power sum of this power, and maximum of some elements can only be equal to sum of those elements. If all the numbers are 0, only one is at max non-zero. Because the numbers are positive, can only be equal to sum of array if at max one number is greater than 0. So the idea is, like, you can probably do a lot of things, but the idea is look at the prime factorization of all the numbers and try to find LCM based on that prime factorization and look at the corresponding product. So this actually solves the problem for us. Each prime divides only one number. And what is the number of ways to ensure in this case? Either I can keep all the elements 0, or for the first number I can choose any power from 1 to 3. So 3 ways. No options here. Here I can keep, otherwise I keep every other number 0, and this is the only power which is non-zero. So I can keep power from 1 to 7. So 7 ways over here. Or I keep everything as 0 and only this power as some non-zero number. And that power can be 2 to the power 1 up to 4. And either all the numbers are 0, or I keep only this as a non-zero. So this would be 1. So the number of ways to distribute 2 power 2 to all of these numbers is 1 plus 3 plus 7 plus 4 plus 1, total 16 ways. Any questions, anyone, on this? At least with respect to 2, we have only 16 ways to distribute that 2 to the different numbers here. If you can get this idea, then we are mostly done with this problem. Any questions, anyone, on the first round, on the idea so far? So now the idea is to repeat it for all the primes that exist for the number power plus 1, and overall idea becomes of prime powers of for all numbers, all primes, and multiply power plus 1 for all of them. And this is F1 overall. So like there are few nitty-gritties involved over here. Like you need to know how to factorize the number. I will skip it, but you need to know that there is something known as sieve using which you can do. You can maintain a lowest prime factor, largest prime factor for each number, and you can repeatedly do it all the time. Like I will not go into those details, but if you are solving F1, then you can know over here. Like you can probably look at sieve. You can look at this algorithm and do some variations of this to find all the prime powers. So F1 is as follows. First, I compute one prime factor for each of the numbers. I keep an array of primes found. I keep a power count for each of these numbers. I go into all the elements. I look at one of the prime factors. If power count is 0, then I have found at least one prime here. Now I count how many times this number divides it. And I do a plus equal to count for this. Now I go over all the primes that I have found. I can keep answer equal to 1. And then I can reset power count be equal to 0 so that the next case, test case works fine. And this is how I am done with F1. Any questions, anyone on F1 before you jump on to F2? For modern time using the AdCoder library, and overall that's where we are. Any questions, anyone on F1? Then we will jump on to F2. Any questions, anyone on F1? Just let me know. Raise some hands or do react something. Okay, I'm not sure if I understood your question. We may choose any power from 0 to 2p. Don't we need to multiply by n, like where to multiply this power at what index? Like, not sure if I understood it. My idea was I'm choosing a prime factor and then I'm looking at how many times this prime factor divides all of these numbers. And the idea is in the new array, this prime will either not divide any number or this prime will divide only one of these numbers. And prime power actually defines how many times at max, how many times that power can divide something. So now, like the problem, the only additional constraint in F2 is like the additional constraint over here is like this. Okay, we have X, then we have an LCM, and which is equal to product. So what can happen is like some prime powers can come from X as well. So what is if for a prime power P, let's say if we have P to the power K over here, then the equation we have is like this: K plus maximum of these powers is equal to sum of these powers. Earlier X was 1, so we can divide it in only one of the numbers. Now the idea is you can have multiple elements as non-zero. All you need to ensure is that maximum of all the numbers which would come from LCM plus whatever power you can get from K is equal to the sum of these numbers. Because product would be sum, LCM would be multiplication. And this should hold for every prime number, right? Any questions, anyone? Now the idea is like we can actually do a DP here. Max seen so far, sum seen so far. And then we look at the next number and we can try to, like, let's say the next power that came up was U. So we can do sum plus U and we can still keep max of mx comma U. So the idea is to do a DP on this part. Now what I am doing is like the same algorithm. Instead of just maintaining the sum, I figure out what all powers I have seen so far. Sum of all the counts that I have seen. Now I iterate on all the primes that I have found. I see how many times it divides by C. Now I have to do the DP on the same part. How much addition sum comes up from? What is the maximum for all the powers and what is like this would be the maximum sum I can get. So a 2D DP. I iterate on all the powers. How much time the current element will contribute? No, like PVR max. PVR sum. And then current value. Now the maximum would be updated to PVR max. Whatever the previous maximum was and whatever the current value is. New sum would be PVR sum. PVR sum. And I keep doing it. Now the number of ways to divide over here would be I divide max for all of these elements. And dp of m, if m is the maximum, then the sum required would be maximum plus ck. And I do take the sum for all the elements and I multiply this by answer. I keep doing it for all the elements. And if there is a prime of x that does not divide any element, then the answer is 0. So that is handled over here. Or I can put it this way. Like this is a check when x but no other element. In this case, we can never make x multiply by that prime equal to product of all the elements. And this is actually after. Okay. Same idea, solve for this prime powers and clear this prime power out. So this is actually after. Any questions, anyone? Like, do let me know if you have any questions. Otherwise, we will move on to problem G. And that would be the last problem for today. Like, do react something. Otherwise, I will move on to F. G problem, and that would be the last problem for today. I would be back in 2 minutes. Just let me know if you have any questions. Okay, can you please explain TL? By TL, do you mean time limit? Do you want to know time complexity or is it something else? Hello. Like if it's time complexity, then this goes as follows. Okay, time complexity. Right. So first, like all the numbers are up to 5 into 10 to the power 5. AI is less than equal to 5 into 10 to the power 5. How many distinct prime factors each number can have? Like I know for sure is 2 into 3 into 5 into 7 into 11 into 13 into 17 is around 500,500, which is more than our current limit. 1, 2, 3, 4, 5, 6, 7. So like the product of smallest 7 prime numbers is more than the maximum element we have. So each number has at max 6 prime factors. So in this case, total number of elements in this my prime power would is that like the sum of number of distinct factors for each of the number. Because for each distinct factor, I am adding it some value over here. Is less than equal to 6. Now in my DP, if I look at it, like the what is the maximum power for each of these numbers? This mx would be equal to 20 because 2 to the power 20 is less than equal to 5 into 10 to the power 5 or something like that. And similarly, this ck is also 20 at max. So this mx is 20 at max 20 and this t is at max 40. And with this, we can figure out each this for loop runs into mx times and t times into t, which is 20 into 40 into 40. This is 16,000 or something into 6 into n. Like this is the overall time complexity here. These are the numbers that I have given you. What another way to put at is like this thing prime count 6 is usually approximately equal to some LG of n or something like that. I am not actually deriving the formula for it, but let's just say it's 6. Maximum power I would get would be log of 2 of AI. And then T is 2 times log 2 AI. Because power of 2 is the maximum value that can exist over here. So my that for loop is mx cube into 4. Like 4 doesn't really matter for the constant factor. So overall time complexity is 6 into n into log 2 of maximum AI to the power 3. This is actually really close to the time limit we have. Time limit is 3. My solution takes 1734 milliseconds or something like that. So this is a crude way to solve for this problem, but this works. Like I doubt the time limit is tight, to be honest. What I can do is I can actually do a grouping over here, and that will probably make my solution a bit faster. Yeah, rather than running it for all prime factor, I just run it for each distinct factor and do a frequency check over here. I did not bother solving for it, but you can actually do it. We have a current value. Number of ways to choose these many elements. F into current count. I would need NCR in my library. And current values should repeat. If current value is 1, it doesn't really matter. Huh. This will actually decrease your time limit quite considerably. So I don't think time limit is tight. Wait 1 second. Oh, expected 3, found 1. So yeah, like DP in this shape is not right. You will have to probably optimize it a bit more, but I'm pretty sure you can optimize this for loop over here. I will skip it for the sake of simplicity and move into the next problem. But you can probably optimize it by grouping these prime powers. That's all I would have to say over here. Like you can probably, rather than looking, you can probably use the number of elements, use something like that. And I'm hopeful it should be able to reduce it. But let's skip it for the sake of this discussion. That's fine. Any questions, anyone? Any more questions, anyone on F2? Else we will move on to problem G. Like only 60 people were able to solve problem G in the contest. And only 15 people were able to solve all of the problems. And I was actually ranked 10. So I believe like this is my third time when I'm in top 10 of a Div 3 or something. So overall problem G is quite hard. I have seen a problem harder than this only once in a Div 3. Back then I was not able to solve that problem. And I would definitely rate it more than 2000 or something. And if you are here, like I would appreciate ki you at least stay till the end. That will give me some motivation to discuss the complete solution I have. And if you have questions, you can always let me know. So that's where we are. Any questions? Anyone so far? If not, problems is the last problem for today. We will discuss it and then wrap it up. Wrap up today's stream. Just give me a thumbs up or everything so that I can start from G. I will assume that no one has any other questions on any of the other problem. Okay, regions in Burlandia form a graph with n vertices and n minus 1 edges. There is exactly one path between two vertices. Formally, the regions form a tree. TLDR, we have a graph with n nodes and n minus 1 edges. And this actually, we have a tree with n nodes and n minus 1 edges. There are Q queries. In each query, a pair of friends located in the in different region is given. So we have two different nodes given in each of the query. They want to know how many segments of path between these regions are hospitable. It is known that in Burlundia, there are two criteria for evaluating relationship. JOR and sum, a segment of path containing some vertices lying on the path from region X to Y is called hospitable if it's non-empty and the sum of friendliness values on this segment does not exceed their JOR. More formally, for each given query, like let's just forget the story so far. The TLR is we are given a tree that has n nodes and n minus 1 edges. And we are given Q queries. In each query, we are given two nodes of a tree. We are given for each query, we are given two vertices X and Y. Consider the shortest path from X to Y in a tree. Let U1, U2, Vk form this path. Let V1 equal to X and Vk equal to Y. We need to find number of segments of this path for which this condition holds true. XOR of these numbers is more than equal to sum of these numbers, where L2 are some segments of this path. So what we have been given is we are given a tree. Let's say we are given some path, some node U to V for a particular query. I would say like let's look at this path as an array of some numbers. Like if you go from one node to U, like all the numbers you find, put it in a some array like this. Now in this array, we have to count number of sub arrays such that XOR of numbers from AL up to AR is greater than equal to sum of numbers up to AL to AR. This is the problem statement for us. Now, a crucial observation here is, let's see how does XOR works. XOR of 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0. For any bits. Here we can see that the value is equal to sum. Here also the value is equal to sum. Here also the value is equal to sum. Here the value is less than equal to sum. So what this boils down to is all the elements, like each bit should appear in at max one element. Because the moment a bit appears in 2 times, sum will increase by 2 and the value will be only once. Because let's say if ith bit appears b1, b2 up to bn times, in XOR side, this should contribute either 2 to the power I or 0 based on sum is odd or even. Or even count. But in sum, it will contribute 1 each time it appears. So the problem essentially says we have to count number of segments L to R such that each pair of element has or equal to 0. In range has or equal to 0. Like this is one of the quick observations, but there are a lot of more things that will come up in this problem. Now my idea is let's first solve a subproblem. Like I will have to probably erase this board once. Like overall the idea is like any bit can be in at max one number. Like for example, if my array is 1 1 0 1, XOR would be 1, sum is 3. And overall, like the sum is always greater than equal to XOR is what I would say. Because if some bit is present in any of the numbers, in a number, it will do plus 2 to the power I in sum. But in XOR, it can either be 0 or 2 to the power I. So rather than looking at this equality this way, here we need XOR is greater than equal to sum. But what I am saying is, you choose any set of numbers, some of those numbers will always be more than or equal to XOR. So in reality, the opposite of this holds true. And the only time when this equation can like forget about XOR more than sum, that can never happen. The best you can get is XOR is equal to sum, and XOR would be equal to sum only when each bit can appear only once in all the elements. For example, if zeroth bit is there, then if zeroth bit is in two numbers, then sum it would add two times, but in XOR it will contribute zero times. So the only way you can make XOR equal to sum is the zeroth bit appears only once on both of the sides, or zeroth bit does not appear at all in any of the numbers. So like the reverse is always true, that sum is always greater than equal to XOR. The best you can get is sum is equal to XOR, and that will happen only when all the bits appear at max once. And all the bit appearing at max one means, like, if you have any two numbers, there would be no bit that appears in both of them. That's why it's equivalent to saying OR of any two numbers is zero. Because if any bit appears in at least two numbers, they will contribute zero to the XOR, but two times to the sum. Any questions, anyone so far? So let's solve the next problem. Let's say the tree is rooted at zero. So the tree looks like this: zero. And let's say, like, each pair of queries in the different u comma v is in each u comma v is in different child of root. So I am trying to solve one slightly easier version of this problem, where I am saying, like, every node is in a different subtree of zero. So a path like this exists. A path like this can exist, but we don't have a path that starts and ends in this subtree. Orange, purple is not allowed, but pink, green, etc. is allowed. Then how can we solve this problem? Let's first solve for this problem. Then we will go back to the original problem where another condition comes up. Now, in this case, like, the observation is, like, zero will be present in every path. And our path will look like this. We have a zero. Yeah, like the first observation is basically XOR is at max sum, and XOR will be equal to sum when, like, all the elements have OR as zero. So, so every path will look like this. We would have zero in between, and a node would either look like this: some nodes from here, then zero, and some nodes from right side. This is one way to form some paths. Another way to get some elements would be everything is on this path from u to root, or everything is from this path where we have from v to root. This sounds right. If I am saying that every uv in your query is in the different subtree of 0, then the path from U to V will always contain a 0. And my path will look like this. Either I would have some prefix from 0 to U path and some prefix from 0 to V path, or the path is complete in these nodes. And let's try to first solve this problem and then we will go to the original problem. So here what we really need is from all nodes from 0 to X, let's ignore 0. For every node, X to some child of 0, many nodes have or equal to 0. Like pairwise or is 0 or disjoint sets over there, whatever we call it. And we also need like the prefix length as well, so that we can join it with the other half as well. So you can probably try to do it with the DP on trees over here using some DFS. That's the first problem that we have to solve for. So this is a function where we have to solve for and we have a given root. First, let's say I'm doing some black magic. Like this is some magic. This finds all queries that have and points in different subtree of root. Like I will skip quite a lot of things here because I rate this problem to be more than 2000 and due to it would be E and F. And I am just throwing you the idea, and if you try to upsolve it, that would be great. Now I am doing a DFS over here for each of the child of the root, where I have U and P. I also have the suffix of disjoint subarrays that end at the particular node. I have the number of distinct subarrays I have found from U up to the root. And I also maintain the list of distinct suffixes I would find. And one more variable, can I still extend prefix or not? First, let's just forget about what this is, if blocked is. Let's just say this is like this node should not be considered in your DFS. Then I look at the current value. I first try to add current element to all the suffixes that I have. So by suffixes, I mean I have met a node U. I try to look at all the paths that are from U up to some parent of it, such that the OR still remains 0. Like there are no elements that say same bits. This was the suffix for the parent, so I'm trying to extend it with my current node. We can have one path with value as the current node only that starts and ends here. And then I go through all the suffixes. If I have found any OR with the current value, I skip it. Now I am done with it. Otherwise, I see what are the new bits that I could have found so far and what was the count of that length path. And if that value is equal to the distinct value, then we add it in the OR. Otherwise, we put it. You can possibly use a map wrap, etc. over here, but this was easiest to implement using a vector of pairs. So this is the list of suffixes that I can have from my current node. So let's forget on this one. So now if I add all the suffixes that have distinct constant, this would be the number of paths that end at the current node start somewhere in the path and still gives the jaw 0. So I add it in the current value as well. So I go through all the queries that have u as one of the endpoint, and I add this current sum in my answer. Like I'm doing it, trying to solve it offline, where I first read all the queries and then solve it. Number of paths, child of root and u, that has zero or. Now for each path, I am also maintaining the number of paths from root up to this value where all the elements are distinct. That is maintained in all the prefixes from the child up to this value. And I try to, if I'm allowed to extend the prefix, then extend it with the current value. If the prefix was empty, add current value to it. If prefix and the previous values have or at least one, then I cannot extend it. Otherwise, if it's zero, add it. If it's non-zero, you do it. So this will actually give me number of paths that start at root and end somewhere between 0 up to u and has 0 on. So I also add that to all the query count this way. So like the only remaining pieces I would be left after this is the path that contains 0 and the path that contains both of these halves. So for this, I just keep a track of all the prefixes that I have seen for each of the node. Now I go over all the queries I have. First, I had one taken, and I look at prefixes for u and v. Point between root up to u and other and point between root up to v. If these share any of these root, and we also have root in between. If any pair of elements share a bit, we skip them. Otherwise, the number of paths would be the count of all such paths. And this solves the problem for me. Now, like this would overall be the solution. I haven't gone into all of the details, like it's quite close to the end of the stream. But yeah. Now the idea is you have something known as centroid decomposition. The crux of this problem is all like it splits each subtree into smaller parts all the time. This first finds a node which we call a centroid, process all the queries, that pass through centroid, so and then delete centroid from the root. So it would be the overall algorithm is like this. There is some special node. We don't are not going into the details. The idea is you process all the queries that have a path from this node, and then you simply delete this node altogether. And then recursively solve for each of the remaining subtrees. Solve for each of these subtrees. And the crux of this problem is doing it with this centered path will give us n log n iterations. While if you do it without centered, it could be something n square or something. So overall, this function, solve function, would be called n log n times. And even the sum of all those times subtree sizes, etc., would be n log n or things like that. And like these prefix suffixes, etc., would not be more than log ai. And overall, our time complexity would be like this. Like this function takes some, if there were k nodes in the subtree, of root, this takes around k log ai times plus the number of queries log ai square. This ai square is this for loop. And doing it with the centered decomposition will ensure that sum of these k is n log n. So overall, my time complexity is n log n ai log ai plus q log n log square ai. That would be the overall time complexity. I have skipped few things, but I would strongly recommend like you try to solve centered decomposition problem and then jump onto this problem. Huh. Like you can actually lay green. Okay. You can probably look at Glenn Cole's centered decomposition video. over it. And you can probably start with this blog for business. Like, is it doable without centered decomposition? Possibly yes, but I believe the code would be even a lot more messier than what we have with centered decomposition. So, like the TLDR for problems is first learn centered decomposition and then try to see how you can solve path queries from centered decomposition. Back in my days, I believe this was the blog I read. Okay, I don't have the blog handy, but that's where you are. And without knowing central decomposition, I don't think you can possibly solve it, or you will the problem would be even more harder to solve it without central decomposition. So definitely not a div 3 problem. This would be an E or F problem in a div 2. I'm not sure why folks have added it in a div 3. So this is actually the second hardest problem I have seen in a div 3. The hardest one was probably 2800, 2900 or something with that even I was not able to solve. So this is where we are. It's close to 3 hours since we started this stream. One last call. Any questions, anyone, for any of this problem? If not, then we would be done with this stream. Thanks a lot, everyone, for joining in today. And like this also explains the fact that only 60 people solved it in the contest, and only 15 people were able to solve all of the problems. So quite hard. What do I rate F2? You can actually look at clist.by for the rating of the problems. Clist rates F2 to be around 2400 and G to be 2800. So yeah, like this does aligns with the number of ACs, etc. we have seen on this problem. So like to be honest, these were the problems that were for due 3. And these were the problem. Let's just say author had an extra problem remaining, so they decided to use it. This was even fine. Like usually Div 3 does have 2300, 2400 rated problem, but this was hard as far as Div 3 standards are concerned. So like let's just look at the comment section and see what other folks have done. So like time limit seems tied to me n square log n. Like this is definitely like they did not wanted any n square log n solution to pass. That's why n was 6000. So time limit is not tight. The solution is not. Okay, some hacks on E are getting unexpected verdict. It looks like someone is hacking time limit on E. Not sure why these are getting hacked, but yeah, that's where we are. So editorial isn't out yet. So thanks a lot. Do like, share, subscribe. Um, with this, we are done for. Is E is more brute force than DP? No. Yeah, like I won't call E to be a DP problem. So thanks everyone. That's where we would wrap up today's stream. And thanks a lot.